Hello friends, welcome back to ANLIST channel. Here the second part of heat transfer by natural convection. Let's start. So we already did the mesh in the part 1. So now update the mesh. We already now we have want to open this mesh into the Fluent, right? So it's a double precision and solo pose I made it to 4. Okay, let's start. Yeah, now it's opened in Fluent. Now you can see the mesh model in this Fluent. You want to change the unit. So here I am using temperature in degree Celsius. So select temperature and change it to degree Celsius. And here I am doing transient and gravity we have to enter. See, you can see the y direction. So minus 9.81. That's it. Next, choose the models and on the energy because the temperature is here. Here is we are using temperature as a factor. Next, I choose that laminar. Double click on laminar. Okay. Next, choose the material. So fluid here is air. So make change the incompressible ideal gas, the fluid, because density is a matter in this condition application. Solid is I'm using the aluminum sample. Open this cell zone. Make sure air fluid is in the fluid and the sample is in the solid. Okay, make sure it's air and sample is solid. Okay, that's it. Next, go to boundary conditions. It's important. So we already pre-named that boundary of in the machine while machine. So here is walls. So all surroundings I have given the name walls. Okay, so I have you. It is in a via system coupling. Okay, next is heater wall. So we have 6 heater coils. So we have to assign the temperature output temperature. So temperature is changed to 1000 degrees Celsius from each coil. Okay, then okay, that's it. Next goes to mesh interface. So here is the mesh interface between this air and sample. That means fluid and sample. So already done. It is automatically created that contact region. Okay, so you can highlight the zone where when we click on that particular wall. Okay, so just check on the highlight zone. Next, go to solution. So method I have used the simple C, this one, and green goes gold ball. Okay, for this particular application. Next, monitors. So we have to give the residual the values for the convergence. Make it a minimum lower value. So copy paste of this to all x, y, z velocity in continuity. For this energy, I want to give very less value convergence. Next is report files. We have to create some report files where the data are saving. So we can create a we can plot that temperature with respect to time. So in particular time, what will be the temperature? Like okay, so we have to find out the temperature on the sample. That is our ultimate aim. we choose the sample to air connection, that wall, put the plot, and okay. Next, the go to the plots. So already files created in the on the report. Double click it. Okay, you can see XY label. The first X-axis will be time and Y-axis will be phase at average of temperature on the sample. Done. Next, we will do initialization. So here I am doing standard initialization all the zones, and this temperature initial values 30 degrees Celsius. Initialize. Next, if you want to see the, because it's a transient, everybody interested to see the what's happening while processing. Okay, so click on the solution animation. Okay, residuals and report files inbuilt, it's already there. So whatever you want to see, any particular contour on the face or plane, that variation in the temperature, like a gradient. So here I'm creating new plane. Okay, so that plane, okay, it's in this YZ direction. Create, close. So we can see the plane 8 here, and I want to make another plane horizontal, that is Z and X. Create. Okay, so name is 9. So if you save and display, here we have to select the temperature counter, because we are our ultimate aim to find out the temperature on the sample, right? Okay, now time for run the calculation. I have put one time step size is 1 second, and the number of time steps are 60, and the iteration I changed to less. Even you can use more maximum iteration value, even 20, 30, 50. It will take more time and the value will be accurate. Okay, so let's start the run the calculation. So parallelly you can see the uh, changes in the values. See, you can see 2 seconds the temperature will be approximately 30.05. Even you can see the contours, the temperature gradient. See, temperature starts from the coil wall or the coil heater coil, then it is slowly spreading out. Okay, during the due to the convection. It's quite interesting. See, after sometimes around 12 seconds, the temperature will be around 32.5 degrees Celsius. So it's recording while run the calculation. After 30 seconds, it's a temperature on the sample in 42 degrees Celsius. It's an average temperature on the sample phase. That's what we have given the facet, average facet value. After completion of this run calculation, you can see the final values. You can see the screen, on the screen residuals and the counters. Okay, so if you want to get these values, if you want to get the final values and images, go to results, graphics, this counter, it's already appearing, this one, display, right, the same display. So you just check it. You can see the temperature difference on this plane. So blue color is the sample. So after this 60 seconds, 1 minute, that means 1 minute, 93.6 the temperature on the sample, average temperature on the sample, right? So here you can see this heater is here, uh, heat is coming out from this heater coil. spreading on this area by natural convection and slowly heating the sample. Okay, so now go to particle path lines, right click, display. Okay, now you can see that path lines, that this path lines created by velocity, but I had given this temperature variant on this direction lines. Okay, if you want to see more better visualization, right click, edit, take this value, you can move, draw the mesh, display, close, then save and display. Yeah, now you can see it looks looking good. You can see the heater wall, then heater coils and sample inside. Right now I would like to show this. I just want to animate the temperature, the movement of this velocity, that means the fluid towards the sample. For this, the edit screen itself, you can click it, pulse, and just wait. It will take some time. You can see the movement of the fluid while heating. Okay. If you want to stop this movement, stop this one. And if you want to see on a surface, for that you have to make one surface, you have to click on the surface. If you want to see the path lines on the plane, just unclick it and save and display.
Thank you for watching this video. If you have any doubt on this analysis or any particular area, please email me. My email address is analystcadcae@gmail.com.